Hey everyone, and welcome. So we've all been there, right? You're using an app, maybe one you built, and over time it just starts to feel slow. It gets sluggish, it becomes unresponsive, and sometimes it just crashes. It's honestly one of the most frustrating things for a user and an absolute nightmare for us as developers.
So what is actually happening under the hood? What's causing this digital decay that turns a really snappy, fun application into a frustrating, slow crawl?
Well, more often than not, the culprit is this sneaky little villain right here, memory and resource leaks. Now, I know what you're probably thinking. Wait a minute, doesn't JavaScript handle all the memory stuff for me automatically? And you're right, it does. It has a fantastic system for that. But here's the thing, it's not a magic bullet. It can't clean up everything, and that's exactly where we, the developers, need to step in.
Okay, so to fix the problem, we've got to understand it first, right? So let's dive into what these leaks actually are. I've got a couple of really helpful analogies that make it super clear.
So, I want you to imagine your app is a super busy, bustling restaurant. JavaScript's garbage collector, or GC for short, is kind of like the cleanup crew. They're constantly moving around, clearing away dirty plates and leftover food that customers are done with. Basically, they find anything that's no longer being used and they just whisk it away to make space. It's an incredible, totally automatic system.
But here's the catch. What happens when that cleanup crew can't actually tell if something is trash? What if they think someone's still using it? Well, that is where the leaks start to form.
So this really boils down to two types of problems. On the one hand, you've got a memory leak. Think of this like the forgotten coat. A customer leaves their coat behind in the restaurant, they're gone, they're never coming back for it, but it's still hanging there on the hook. The cleanup crew sees it, but since it's referenced, it's on a hook, they won't throw it out. It just sits there, cluttering up space. Then on the other hand, you have a resource leak. This is the running tap. This is where you've used a system resource, like opening a file or a network connection, and you just walked away without turning it off. It's just wasting system power, drip by drip. And trust me, both of these will eventually bring your beautiful app to a grinding halt.
All right, so let's get into the code. How do these forgotten coats and running taps actually show up in our day-to-day work? We're about to look at the four most common culprits and, most importantly, how we can fix them.
First up, culprit number one. Let's call this the forgotten notification. It's all about uncleaned event listeners. So imagine you have a pop-up on your page, and you tell the main window, hey, just let me know if anyone clicks outside of this pop-up, because if they do, I need to close it. That's a classic event listener.
Now, here's the problem. When your pop-up disappears, that little notification system is still active. The main window is still holding on, listening for a click for a pop-up that doesn't even exist anymore. It's holding a reference to your pop-up's logic, and that prevents it from being properly cleaned up. The fix, though, is beautifully simple. For every add event listener you create, you have to have a plan to call remove event listener when you're done. It's that simple pairing that breaks the reference and prevents the leak.
Okay, culprit number two, the never-ending alarm. This is all about forgotten timers. I mean, we use set interval and set timeout all the time, right? To run some code after a delay or to do something repeatedly. It's basically like setting an alarm on your phone.
But here's the trap. If you set a repeating alarm, a set interval, inside a component, and then the user navigates away from that page, that alarm can just keep on ringing in the background forever. It's just sitting there, holding on to memory. This is why you have to be explicit. When that timer's job is done, or the component goes away, you need to tell JavaScript to turn it off, using clear interval or clear timeout.
All right, let's talk about our third culprit, the permanent resident. I'm talking about global variables. Just think of a global variable as, well, a permanent resident in your application's memory. It shows up on the app starts and it never leaves. It's there for the entire party.
And if that permanent resident is holding on to, say, a huge suitcase full of data, well, that suitcase and all its contents can never ever be cleaned up by the garbage collector. So the key here is to be really intentional and, honestly, kind of stingy. Always prefer let and const to keep your variables scoped just to the block where they're needed. And if you absolutely must use a global variable, when you're done with it, set it to null. That's like telling the garbage collector, hey, you can take this luggage now.
And for our final culprit, we've got something a little trickier. Let's call it the lingering memory. We're talking about closures. So a closure is basically a function that remembers the environment, the variables and scope, from where it was created.
It's almost like it takes a perfect snapshot of a room. Even long after you've left that room, the function can still look at the snapshot and see everything that was in it. This is a ridiculously powerful feature of JavaScript.
But with that power comes a risk. The leak happens if your little snapshot, that inner function, is kept alive somewhere, and in its memory, it's holding a reference to a huge, unneeded variable from that original room. Because that snapshot is still being used, the giant variable it remembers can't be garbage collected. The key here isn't to avoid closures, they're amazing, but to just be mindful of what they're capturing.
Okay, so we've seen the common problems, now let's level up. Let's move beyond just fixing mistakes and look at some powerful patterns we can use to write more robust, leak-proof code right from the get-go.
First up, guaranteed cleanup. When you're dealing with external resources, we're talking files, network connections, things outside of your JavaScript world, you absolutely must make sure they get closed. The try finally block is your ironclad guarantee. I don't care what happens in the try block. If it succeeds, if it throws an error, if the world ends, the code in your finally block will run. This is the perfect place to put your cleanup code like closing a file to prevent those running tap resource leaks.
Next, let's talk about a really cool concept, strong versus weak references. Think about it this way. A regular map or set holds a strong reference to an object. It's like putting a leash on it. As long as that object is in the map, it can't be garbage collected. But a weak map or weak set, well, they hold a weak reference. It's more like a sticky note. This means if the only thing referencing an object is that weak map, the garbage collector is totally free to come along and sweep it away. This makes them absolutely perfect for things like caching or attaching extra metadata to an object without accidentally creating a memory leak.
So we've covered the common culprits and some really powerful solutions. Let's pull this all together now and really focus on shifting our mindset from being reactive, fixing leaks after they happen, to being proactive and preventing them from the start.
And here it is. This is your practical, everyday leak prevention checklist. Honestly, just building these 6 habits into your coding routine can eliminate the vast majority of memory and resource leaks from your code. Think of this as your guide to writing cleaner, way more efficient, and much more reliable apps.
And really, this brings us to the core idea of this whole thing. JavaScript's garbage collector is fantastic, it's a brilliant piece of engineering, but it is not magic. It needs our help. A proactive, mindful developer who really understands these principles, that is the ultimate defense against leaks. And it's not just about making things a tiny bit faster, it's about professional discipline and writing correct, robust code.
So I want to leave you with this one question. Think about the project you're working on right now. Based on everything we just talked about, what's one forgotten listener, one runaway timer, or maybe one totally unnecessary global variable that you could go and clean up today? Go find it and go fix that drip. Thanks so much for joining me.